Hi, Session 6, Transport and Distribution Strategies. We will talk about long-haul transportation, short-haul transportation, cost implications of transportation, freight transport problems, and shipment consolidation and dispatching. So what is the difference between long-haul freight transportation and short-haul freight transportation? Obviously, as the name suggests, long-haul freight covers very long distances. Generally, these are cross-border transportations. They use multiple modes of transportation. In long-haul freight transportation, commodities are transported from manufacturer to other facilities such as hubs, distribution centers, retailers. This kind of transportation uses multiple modes of transport like air, rail, and sea. Short haul freight are goods that are transported by road between pickup and delivery points, generally within the same geographical area. Short haul freight operates in shorter time schedules due to the local running routes. There are generally two main groups of freight transport. They are privately owned carriers, where freight is moved from a restricted number of locations like warehouses to retail locations by private entities. Public carriers comprises several traffic classes and is characterized by location, commodity, and tonnage. This diagram shows how a long-haul freight transportation system works. When the consignor ships goods, he can ship it via full container load or he can ship it via less container load in loose mode. If it is full container load, generally the process is much clearer. The containers are loaded and via a container ship, it's shipped to the consignee's location or country where customs clearance takes place and the goods are delivered to the consignee. For part loads, there are many points at which goods are handled due to the need for consolidation in order to make economic sense. For long-haul freight, the preferred mode of transport is public carriers involving multimodal transport services. Organizations should focus on the operating costs involving long-haul transport operations. These are generally concerned with wages, fuel consumption, vehicle depreciation if you are owning the vehicles, maintenance of vehicles, insurance, and administration. Costs paid by a carrier from transporting a shipment can be arbitrary because different shipments will share common costs. Example, less truckload, where several shipments can be moved by the same vehicle, making it less clear how much each shipment actually costs. There is also the truckload costs of empty trips, where it is necessary to move empty trucks from its base location to a pickup location. Other operating costs are cost of hiring a vehicle. If you are hiring a truck to transport your goods, cost of a shipment when a public carrier is used. An example of this is a container ship line operating once a month from Rotterdam to Mumbai with an intermediate stop at Cape Town. A consolidation type transport network system comprising of road and rail or sea and airlines. In this kind of network, an end of line terminals could be placed where smaller shipments are delivered usually by a fleet of vans. The other operating costs could be handling costs, which are usually devised by the logistics company. Handling costs are generally costs incurred by container or pallet, loading into a container onto outbound vehicle and reversing these options at the destination. These graphs depict how transportation rates and costs are influenced by the weight of the packages being transported. Figure 6.1 shows how the transportation cost increases proportionately with the increase of the weight of parcels. Figure 6.2 shows how the transportation rates for LTL trucking is more economical when the weight of the packages increases. Figure 6.3 shows the transportation rates for full truckloads. Transportation costs for TL trucking are influenced by the number of truckloads or container loads rather than the number of parcels or packages being transported. A common issue in transportation is finding the least cost allocation over time of vehicles and their crews. In air and rail transportation, regular air or rail lines are scheduled. Example, DHL Airlines operate at night. DB Schenker and Freightliner operate in the UK. Demand for transport varies throughout the year. Logistics companies will usually carry a base load of owned fleet, but use hired vehicles when operations are ramped up. This follows the least cost mix of owned and hired vehicles. This is a case study. Fast Truck Services, a transportation company in the UK located in the West Midlands, provide door-to-door deliveries. The company owns a fleet of 20 vans, and when demand exceeds fleet capacity, they outsource to third-party companies. In 2004, the number of vans required on a weekly basis is given as follows. During the following year, in 2005, the company decided to redesign its fleet in order to decrease the cost of transport. Assuming that owning a vehicle costs 10,000 sterling pounds, fixed costs are 8,000 sterling pounds, and variable costs are 2,000 per annum, what would you do to reduce transportation costs for fast track services? This is a classic operation problem for logistics companies. We will discuss this in a classroom setting in the future. No organization can fully sustain a fleet of vehicles that can cater to the demand of transport requirements. They need to follow a mix method where when the demand is high, they have to resort to hiring vehicles. What is shipment consolidation and dispatching? Manufacturing companies must decide which is the best way of delivering orders to customers over a specific time period. This is generally referred to as the planning horizon. This involves best mode of transport for each shipment, how orders have to be consolidated, how shipments are scheduled and routes taken, number of pick-up and drop-off points to take. Let us look at planning and resourcing activities for road freight transport. The costs involved in road freight transport are associated with the running and operations of vehicles, fuel and maintenance. Driver management, using of tachographs to provide an accurate analysis of fleet efficiency. Replacement, fleet managers should identify vehicles that need replacing and what type of vehicles to be purchased or leased. Security and tracking. Fleet management software allows for real-time tracking of packages. Vehicle data enables improvement of operations, security, and service. Freight terminals need to be designed in a particular way that will sustain the operation as well as provide the required service efficiently and effectively. Freight terminals are where goods are often classified, consolidated, and stored for a short period of time to nationwide distribution. These operations include activities like cross-docking, package handling, repacking. Examples of these are UPS, FedEx, DHL, Airfreight, etc. Fleet management software has been used by a lot of organizations today to manage their vehicular fleet. There are a number of software packages that are available that can be used. Example of one is Paragon software. Fleet management functions. Maintenance and scheduling is very important function in fleet management. It includes service life of vehicles, both routine and non-routine maintenance. Then there is vehicle parts control. We need to have a good inventory control mechanism to manage spare parts of vehicles. Administrating the fleet, vehicle and fleet cost, overall fleet profitability. Tachograph analysis, input data analysis of driver and vehicle performance. The tachograph data produces charts on things like rest time, driving time, break times, any details of infringements to the organization's transport policies. These things can be tracked by tachograph data. There are two main types of freight transport, primary and secondary. So what is primary transport? Primary transport involves movement of full loads on large vehicles to a single delivery point. That is, example, a national distribution center. Goods are then moved from the national distribution center to regional distribution centers. Secondary transport systems involve the movement of goods on smaller vehicle roads from the regional distribution centers to retail stores or probably to customers as well. This may include several drop points on the journey. So key points in primary transport. Vehicles operate for as long as possible, 24 hours, 3-shift basis in order to maximize vehicle time. Return loads to maximize the use of vehicles. Backloading drives the decision to outsource to general hauliers. Use of on-vehicles handling equipment is less important in the delivery operations. What are the key points in secondary transport? Customers often restrict delivery windows. Therefore, scheduling activity for vehicle use is more critical. Service, face-to-face with customers and inventory reduction in retail to increase size of selling space in store. Storeroom space is kept to a minimum. Continual replenishment of stock is more crucial. Specialist vehicles developed particularly for secondary delivery. Grocery multi-truck, compartmental trailers, etc. So what are the transport resource requirements? Routing and scheduling methods determine transport resource requirements. Routing planning identifies the appropriate resource to schedule the number of vehicles and drivers needed in any given operation. So there are two key areas in routing and scheduling. Determine initial fleet resource requirements and identify effective vehicle schedule. There are implications for routing and scheduling for both primary and secondary transport systems. Examples to plan journeys for vehicles operating from a single depot, delivering known loads to specific customers and returning to the depot after completing the journey. So what are the constraints in transport? Constraints in freight transport comprises what? Weight, volume and vehicle capacity. These are not unlimited. There is always a limitation in these. Loading and unloading times. These will depend on how efficient the transport route has been. Whether the vehicle was able to reach a destination at the expected time. Different vehicle speeds. Speed also can be influenced by road conditions, weather patterns, etc. Access restrictions. There could also be issues of road closures due to whatever reasons. So what are the objectives of routing and scheduling? Maximum time vehicle is used, maximum capacity utilization, minimize mileage, minimize number of vehicle used, ensure customer specific delivery requirements are met. Example, time deliveries, vehicle restrictions, etc. So achieving these objectives would ensure that the efficiencies and effectiveness of the transport model that is being used is achieved. Vehicle routing and scheduling issues. There are 4 areas for consideration. 1. Strategic issues. These are associated with long-term aspects of routing and scheduling, particularly where there are regular deliveries of similar products. 2. Tactical or operational, where routes are scheduled on a daily or weekly basis, such as parcel delivery, spare parts, contrast haulage companies. Demand for quantity is difficult to forecast in this, and it is impossible to schedule vehicles based on use of historical data. So logistics providers need to use real-time data, which fleet management software incorporates. Third, interactive. This considers variations in scheduling throughout the different times of the day and week. Need to constantly appraise demand. This is not easy to perform manually. You need technology to assist you in this. Planning. There is a constant requirement to do what-if scenarios in order to plan and manage change proactively. Examples of planning transport resources. Third-party contractors respond to invitations to tender and use data to cost out a given operations more accurately. Manufacturers identify resource implications for different orders, maximum minimum order size, and costs associated with order ranges, and of course cost increases. Own account operators identify implications and changes in transport legislation. There are many routing and scheduling algorithms that can be used to plan and manage your fleet routing and schedules effectively. This we will discuss in a classroom setting. There are data requirements to run fleet software efficiently. Demand data. This would include location, name, town, postcode, quantities, deliveries. Distance travel data involves the physical distance between places. Can be obtained by using geographical maps. Coordinate method. Distances measured in straight lines as the crow flies or aircraft flies. Discrepancies are factored into approximate road distances. Digitized road networks. Most computing scheduling packages use the road digitized network. This comprises major roads, motorways, etc. Software provides highly accurate travel distances because they also include travel speeds along routes. Customer service constraints. Specify delivery times, lunch breaks, delivery windows, early closing days, access restrictions, unloading restrictions, parking and paperwork problems. There are many of these that can impinge adversely on the efficiency of fleet management. And to run your fleet software effectively, you need to quantify all of these. Vehicle restrictions. Type of vehicle available, number of vehicles available, need to preload trailers, mixed fleets, vehicle capacity, etc. Then we need drivers constraints, comprise working hours legislation, shift patterns, number of drivers available, licenses and training of different overseas logistics providers. Then we have route factors, road infrastructure, maximum number of calls per route, multiple trips, the maximum trips that can be done per day, simultaneous delivery and collection, product and unit load, weight dimensions of different loads, weight dimensions of different products, variable load times, separation of products, etc. So use your software effectively. You need these data segments. The more accurate the data, the more accurate the final reports would be from your fleet software. So what are the steps in manual routing and scheduling if you do not have a software package? You need to establish delivery data and parameters, need to identify geographical area, need to determine demand, especially historical demand on specific routes, need to determine customer drop requirements. Some customers may not want you to deliver after a certain time of the day. Allocate demand resources, decide on geographical routes, plan trips, plan routes, calculate vehicle and mileage traveled, calculate delivery cost, and calculate vehicle utilization.